Second CPU algorithm is SJF, that is the shortest job first. So this is the program, the shortest job first. Here we need to include some header files. Here we have included stdio.h, as we know, for the standard input output library function for the printf and the scanf purpose, and the main function. So inside the main function, we declare some variables of type integers, that is BT means the burst time and the P processes, and the waiting time, turnaround time, that is the TAT, and I, J and N total we initialize it is as the 0, and position and the temporary variables, and some floating point variables, that is average wait turnaround time and the average waiting time. And we have given the limitation for the burst time, that is up to 20 we can enter, we can take, and for the process and the waiting time, turnaround time is also 20 each. And here enter the number of processes. So here printing a number of processes, and for the burst time, for the burst time here, if I is equals to 0, I is less than n, I plus plus means here if 0, if for the I plus 1, the burst of the burst time will print for the pi values. And next, and that is also the it will, and this for loop is for the burst time, and the second for loop is for the position, where it is actually the for the IDs. And also next one is the turnaround time and the waiting time, and this one is with the waiting time and the average waiting time. And last with the average waiting time, the need to calculate the turnaround time means we need to add the burst time and the waiting time of the process I. Okay, now as for the for loop. And next is for the next, calculate the waiting time, turnaround time, and the burst time of the process. We have taken the number of process, and this is the for loop, and this is the for loop. And as we know that every how many, it depends on how many processes we have taken here, number of processes, that is n number of processes we have taken. We are printing the process, how many processes we have entered, and the burst time, turnaround time, and the waiting time. And lastly, we can calculate the average turnaround time, to calculate average turnaround time, the total number of processes we need to take, and the average time of the P1 with average waiting time. So this is how it will work. So at last we can calculate the average waiting time and the average turnaround time of the each process. So it should be divided by an average turnaround time of the total number of processes, and how many number of processes we have taken should be divided by n. And this is the output. So it will ask enter the number of processes. Here we enter 3, and enter the burst time 253. Means here the shortest job means first means the process which have the shortest burst time. So we can here see the P1 has the 2, and P2 has the 5, and the P3 has the 3. So here the P1, the first will execute the P1. Why? Because its burst time is only 2. And next the P3, the order you can see here. The P3 will execute, after that the P2 will execute. Why? Because as compared to the P3, the P2 will have the less number. So that is 5. So the P3 will execute after P2 will come. Okay, so after that, to calculate turnaround time, the burst time plus waiting time is equals to 2 plus 0 is equals to 2, and the turnaround time of the P3. So P3's burst time is 3. So that's why it will come after P1 and before P3. Before P2. So 3 plus 2 is 5 turnaround time, and the P3's turnaround time is 10. So this is the it is calculated. And average waiting time, how the average waiting time, the total, the average waiting time 5 plus 2 is 7. 7 divided by 3 is 2.33 something point will come. So like this, it will execute the average turnaround time and the average waiting time. calculate average waiting time. So this is how the second program will execute.